Okay, so I'm at 40 over 2 times the integral of u to the 5th du. If you want to go ahead and simplify, what do we know about 40 divided by 2? 20 times. What is the integral of u to the 5th?
1/6 u.
You add 1 to the power and divide by that new power. So 1/6 u to the 6th. If you prefer, you could say u to the 6th over 6. This is an indefinite integral, so we need to tag on a plus c. And then my goal is to just kind of clean it up here at the end. And did we start with u's originally? No, so we don't want to end with u's. Meaning, can I replace u with whatever it was originally? Yeah, u was x squared minus 4. So I can, this is 20 times 1/6. Now it's u to the 6th, so my u is now going to be x squared minus 4 to the 6th plus c. There's one last piece I can clean up. What do you know about 20 times 1 over 6? 20 over 6, which can reduce to 20 and 6 can both divide by 2. So I could write it as 10/3. X squared minus 4 to the 6th plus c. Plus c is off the screen.
So we don't have to focus about chain rule or anything like that.
Right. So, I mean, what we've been doing is kind of leading into this, okay? Because what happened is, where did my chain rule happen? My chain rule happened when I took the derivative over here, and it was just a matter of matching everything up. Okay? Questions before I move on? Okay. Let's try example 2 then. And you can still kind of think in, okay, if this was kind of our integration by guessing. You know, what do you see as the overall thing? What would you be guessing? Because that will help us get to what we want to use as u. If you look at the current main function is this square root of b plus sine ax. The square root in the denominator is the same thing as saying b plus sine ax raised to the negative 1/2 currently, right? So we're expecting by the time we get to the end, we're going to have b plus sine x raised to the positive 1/2. Now, what that means is, what do I want my u to be? What is the inside piece there? U is going to be b plus sine of ax. And notice it did state there that a and b are constants. That means they're numbers. Before we do too much here, because there's probably some concern about that cosine up there, take the derivative of u. The derivative of u is so derivative of u is du. Derivative of b is a number, so the derivative of a number is nothing. Derivative of sine of ax. The derivative of sine of something is cosine of something. So cosine of ax times the derivative of the something. So what's the derivative of ax? A. And then we're using our differentials here, so times dx. Okay, my job is to make sure it all matches up now. As I set my integral up, scooch it over here a little bit. What about this denominator? It's the square root in the denominator, so that is currently what? Negative 1/2. b plus sine ax, what am I using? That's u. So that main piece right there that is accounted for is u to the negative 1/2. What about the pieces in my numerator? Are they all accounted if I just put in a du here? Does it all match up? So what matches up? Cosine of ax matches up with cosine of ax. Dx matches up with dx. What doesn't match up? The a in my derivative doesn't match up, so what am I going to say to do with that a since it doesn't match? So this, everything is replaceable, so divide the a over. I'm going to have du over a equals cosine of ax times dx. So what am I substituting into my integral in place of cosine of ax dx? What is cosine of ax dx equal to? Du over a. This is times du over a. Did I account for everything up here in my integral? The 20 needs to come down, and it's just a constant, right? So easiest is probably they recommend that you pull the 20 out front. You could leave the 20 within the integral if you want. It's just a constant. It doesn't matter. Now notice my integral is all in terms of u. And that's what I want. All my x's are gone for the moment. To make this look a little nicer, make it a little more understandable, what else do I need to pull out front? The a, right? That's just a constant. That's a number. That's like saying divide by 4 or something. So if I pull that a out front, I already have a 20 out front, and so this is 20 over a times the integral of u to the negative 1/2 du. Okay, I'm going to keep my 20 over a out front. What is the integral of u to the negative 1/2? What? I don't want to put the sine x in right now. I'm just trying to integrate u to the negative 1/2. 2u to the 1/2 if you want. The idea is you add 1 to the power, right? So it's u to the 1/2. He said 2u to the 1/2. Officially, if it helps you, do you need to see that it's dividing by 1/2? And why did he say 2? Because dividing by 1/2 is the same as multiplying by 2. And then, of course, don't forget when you integrate to, say, plus c. So, dividing by 1/2 is multiplying by 2. Options for where you want to put the 2. If we bring it up and say 2u to the 1/2, what's that also going to multiply by? The 20. And 2 times 20 is 40. So how about 40 over a times u to the 1/2 plus c. And at some point, what do you have to do? Yeah, don't leave your answer in terms of u. My original problem was in terms of x, so my answer should be in terms of x. So 40 over a times u b plus sine of ax raised to the 1/2. And lastly, plus c. Questions there? Okay then. Example 3. What are you thinking? Okay. We're looking at the inside. U is x minus 1 because that's under the radical, and the radical is going to be what ends up integrating. If u is x minus 1, what is du? If we take the derivative of that, 1 dx. So basically, du equals dx. Okay, let's see where we're at. The square root of x minus 1, what am I going to call that for right now? Except I'm not going to say x minus 1 to the 1/2. I'm going to replace it with u. So the square root of x minus 1 is going to be u to the 1/2. What do I know about dx? Dx is exactly equal to du. So I'm going to replace dx with du. What about this 7?
What about the where did the x come from? Because we don't have that in our du equals.
It's because she took the derivative of something with an x in it. So she got the 1 dx from the x minus 1.
Are you talking about this dx or this x?
Well, I'm saying, like, in order to match it to see if everything's in x, so we have a dx, then we have a dx in the equation, but we don't have an x, and we don't have an x in the du equals.
Hold that thought.
Okay.
Hold that thought. I was getting there. Okay. I'm trying to match up all the pieces, and we're going to get to the end, and we're going to have a problem, aren't we? Is that what you're seeing? Yes. We'll deal with that problem here in a moment. Okay? So, we're okay with those two parts. They matched up perfectly. The 7, what have we been doing with a constant? Putting it out front. I'm going to scooch my integral back. I'm going to put my 7 out front. Did everything match up? Almost. It's okay to have that 7 not match up because it's just a constant. We cannot just carry that x down in the problem because I'm integrating in terms of u. I need everything in terms of u. So, this is a little bit different one. What we're going to do, go back over here. We had u equals x minus 1. Can you tell me what x is in terms of u based on this equation right here? In other words, can you take u equals x minus 1 and solve it for x? X equals what? Not u minus 1. U plus 1. Because if it's currently x minus 1, how do you get x by itself? You add the 1 over, and so that becomes u plus 1. So what I'm suggesting here is that we know u is equivalent to x minus 1. Well, for that same reason, x is equivalent to u plus 1. So what can I replace the x with that didn't go away like we wanted it to? U plus 1. Now, part of us wants to say, ooh, this didn't get much better, but it is doable. Okay? First of all, we have a u to the 1/2 times u plus 1. We're going to multiply these together. We're going to distribute. So I'm going to carry down my 7. I'm going to carry down my integral sign. And I'm going to distribute, meaning u to the 1/2 times u and u to the 1/2 times 1. What would be u to the 1/2 times u? u to the 1/2 times u means this is u to the first, yes? What do you do when you're multiplying and the bases are the same? You keep the base and add the exponents. What's 1/2 plus 1? And there's the 3/2. Not something we use every day, but it's something you're supposed to know. Does that make sense? Okay, so u to the 1/2 times u to the 3/2, plus u to the 1/2 times 1, u to the 1/2, times the u. Can I integrate those individual terms now? They're just powers, right? So we can integrate them. So I'm going to keep the 7 out front. I don't want to mix it in yet. What is the integral of u to the 3/2? Add 1 to the power, which makes it u to the 5/2. Also means you divide by the new power, so you're dividing by 5/2, which is really multiplying by 2/5. So I'm going to say 2/5 u to the 5/2 plus integral of u to the 1/2. Add 1 to the power, divide by the new power. If we add 1 to the power, it's u to the 3/2. If you divide by 3/2, that's also multiplying by 2/3. In my parentheses, and of course there is a plus C. Bless you. The one step left we have to do is, my problems start off in terms of x, my answer needs to be in terms of x. The other thing I did is I did multiply the 7 in. Not that you'd have to, but I did multiply the 7 in. If we multiply the 7 in, what's 7 times 2/5? 14/5 u to the 5/2 plus 7 times 2/3. 14/3 u to the 3/2. And then if we sub back in, what was u? X minus 1. So a version of the final answer, 14/5 times x minus 1 to the 5/2 plus 14/3 times x minus 1 to the 3/2 plus c. Okay, questions on that? I also have something written down about GCF, but it looks like I just stopped here last year, so we technically could factor out GCF, and I'm guessing the answer key might do that sometimes, but. Okay, are you getting the grasp? Slowly? Okay. The difference of the denominator. It still change the variable. We're still going to have to use our u substitution, but these are definite integrals. Definite means there are boundaries. So indefinite is when you tag on the plus c, because there's no numbers on the integrand. Okay? Now there's numbers on my integrand. There's boundaries. Okay, so this means it's a definite integral. It has a definite answer, as opposed to an indefinite integral, which is just a random plus c, because we don't really know how it turns out. Does that make sense? Yes. Okay, so we're going to start off the same way. What's the big thing we're going to be integrating?
Pi x squared. That's gotta be your u.
Okay. Because we're going to be integrating sine of something, right? So that means the inside piece is my u. So I am going to say that u is pi x squared. If u is pi x squared, let's talk derivatives. Then du is, okay, the pi is just a number, right? So the derivative of x squared is 2x times the pi makes it 2 pi x. And then we're in terms of x, so dx. Excuse me. Okay, yeah. If you start looking up what pieces are going to match up, x and dx are going to match up, right? But is there a 2 pi here to match up over here? Okay, like sine of pi x squared is going to be sine of what? What? Repeat what I asked? Okay, so let me actually backtrack. Pi x squared is what we used for u, correct? So we're going to be integrating sine of u, correct? Now we have to make sure all of our other pieces match up, right? So I have an x and a dx besides. Over here, can I just put du in as it is? Does it match everything up? It matches up x and dx. What doesn't match up is 2 pi, so we need to divide that 2 pi over to be with the du. So du divided by 2 pi is equal to x dx. Now does it match up? Yeah. Because now x dx, what am I going to replace x dx with? Du over 2 pi. Now, here's the catch on this. This 0 and 1 are part of the initial problem, yes? Which means they are tied to the variable x. We have options. We can work this integral as is, in terms of u, get to the end, and sub the x back in, and then use the 0 and 1. Or, what I'm going to recommend is that we change these boundaries, meaning these are x boundaries right now. We can use this right here to change them into u boundaries. Okay? So meaning like the top one is a 1, yes? If I sub it in over here, because these are x boundaries. If I sub it in over here in place of 1, or in place of x, u is pi times x squared, so pi times 1 squared. What is pi times 1 squared? Pi. So what that's saying is that my new boundary, instead of using a 1 on top, I'm going to use pi on top. Do the same thing with the bottom boundary. My bottom boundary is currently a 0, and that is an x value. So plug it in for x. Pi times 0 squared. What is pi times 0 squared? 0. So what's my new bottom boundary? 0. I said new, but it happens to work out to be the same. So when you have to change and use u substitutions, this is my suggestion. Because now I don't ever have to go back and put my x's in. Okay? You don't change the boundaries, you just go back and put x in. Okay. As you look at that integral, do you guys want to bring that 2 pi out front? 2 and pi are constants, right? Then go out front. They're in the denominator, so I'm going to say 1 over 2 pi times the integral from 0 to pi of sine u du. Carry my 1 over 2 pi down. What is the integral of sine u? Negative cosine u. So this is going to be 1 over 2 pi times negative cosine u, evaluated between 0 and pi. And now notice, I'm never going back to x's. I'm just going to finish this off in u's because I changed those boundaries. So 1 over 2 pi times, how does this work? How do I evaluate it? We're going to put pi in, negative cosine of pi, and then what do we do when we're evaluating integrals? Subtract, and then it's negative cosine of 0. Negative cosine of pi. What is cosine of pi?
Negative 1.
Negative 1?
That's positive 1.
So the negative of negative 1, if you would, right, makes it positive 1. Minus negative cosine 0. Or I'm already going to say plus. What's the cosine of 0? My brain had a momentary lack of connection there. I know Jack doesn't, but are the rest of you guys doing this?
Yeah.
Okay, so do we need the review, or am I doing this for no reason?
No, you're doing it for a reason.
I am doing it for a reason?
Yeah. Why does your unit circle over here, the 2 pi is over 0?
Because once you go around, it's also 2 pi. I'm starting to teach unit circle to my pre-cal, so that's why there's a /0 right now. Which means I'll start to put all the labels on there eventually. Okay, so cosine of pi, remember an ordered pair is what? Cosine sine. So cosine of pi is negative 1. Cosine of 0 is 1.
Why is there a plus 1?
On this one,
Yeah.
it was originally the negative of negative 1.
Oh, okay. I was thinking trying to figure out where we got it. I was looking on the board and I was like,
Okay, so we have 1 over 2 pi times 2, which is going to be, I've said 2 over 2 pi, but yes, I was getting there. 1 over pi. I always debate, which step should I take, which step should I skip? I've learned putting the extra steps in doesn't usually hurt. Usually. Usually someone needs that connection, whether they tell me or not. Okay. One last one? It is one last one, right?
yeah.
I thought, that's what I thought I remembered. Okay. The integral from 0 to pi of e to the sine 5x times cosine 5x dx. Okay.
You make sine of 5x.
Because what's the basic thing we want to integrate? E to some power. Okay. So if we're going to be integrating e to some power, we want to be able to say e to the u, which means I'm going to say u is that power. So u is sine 5x. If u is sine 5x, what is du? Yeah, derivative of sine of something is cosine of something times the derivative of something. What's the derivative of 5x? 5, and then times
dx.
Okay. What matches up? What doesn't?
5.
You guys okay with that? I've already kind of set this up as e to the u. Cosine 5x and dx are right there, yes? So what do I have to do with the 5? Divide it over. So du over 5 is cosine of 5x dx. So here, when it's cosine 5x dx, what am I replacing that with? The du over 5. Now, what do I have to do so I don't have to go back to x's later and plug all that x stuff back in?
Tie it to the sine 5x.
Yeah. We need to change our boundaries. So take your current boundaries. So if I plug in pi and 0, so those are x boundaries. I'm going to change them to u. Sine of 5 times pi. Okay.
Anytime it crosses the x-axis at pi.
Yeah. Sine of 5 pi, guys. If you're a unit circle person, here's 1 pi, right? 2 pi. 3 pi. 4 pi. 5 pi. What's the sine of 5 pi? 0. It didn't really matter which one we ended up on, right? It was going to be 0 either way. So that's going to be 0. Then we need to plug our other boundary in. The sine of 5 times 0. 5 times 0 is 0. What's the sine of 0?
0.
0. So my boundaries are
0.
0 and 0. Okay? Not exactly. Now, if we're going to clean this up, and honestly, we could stop right here. Those zeros do tell me something important. Not quite. Okay. 0. Because when your boundaries are the same, think about it. You're going to be subtracting. So you're going to do the upper thing at 0, or the thing at 0 minus the thing at 0. And so then when you multiply that by 1/5, you're already at 0, times 1/5 is going to still be 0. So what I was going to have you do is, yes, you can go ahead and pull the 1/5 out. So it's 1/5 times the integral from 0 to 0 of e of u du. But here's the deal. When your upper and lower limits are equal, the integral always equals 0. And if you go back to that page of rules for integrals, it's probably on there. I honestly don't remember, but. So this equals 0. And I will even put a note, in here stating such. When upper, and it's not just because my upper and lower limits were 0, it's because my upper and lower limits were the same.
Yeah, it's there.
Is it? Okay. Figured it was. Okay. When upper and lower limits are equal, the integral equals 0. It's one of those rules, we haven't really used it a whole lot, so we haven't had to think about it.